everyone, and welcome to day 3, taking a derivative using the chain rule. This is a 2-day topic. We're going to be doing the first day looking at more simple chain rules, and then the second day we'll be looking at more complicated chain rules. So the idea of chain rule is the fact that you're taking a derivative of a composition of two functions. So if we look at this first one right here, we have the idea that we have the derivative of the square root of x cubed plus 1. And we all know that the square root is the idea that it is x cubed plus 1 all raised to the 1/2. And so I have the 4 steps written right here, or typed in, that you break down the derivative into two different functions as compositions, just like we talked about. And then we take the derivative of f of u and g of x equaling u. So you should have 4 equations written down, and then you're going to multiply the two derivatives together. When we talk about this, I'm not going to necessarily use this. I have everything shown here to follow these 4 steps. I'm going to talk about something different. I'm going to talk about the idea of taking the derivative of the entire function, the outside function, the bigger function, leaving the inside the same, and then taking the derivative of the inside. So basically we're going to say the derivative equals the derivative of the outside, leave inside the same, and then multiplied by the derivative of the inside. Let me show you what that means. So let's look at this first one here. The inside is x cubed plus 1. The outside is a derivative of the square root. So broke it down here. This is using the correct mathematical terminology. F of u equals the square root of u. U equals x cubed plus 1. So if you plug u back in, you're going to get the square root of x cubed plus 1. If you take the derivative of each, now notice that the derivative, you can rewrite this as u to the 1/2. The derivative of that, bring the 1/2 out in front, subtract 1, you get 1/2 u to the negative 1/2. The derivative of u, x cubed plus 1, is just 3x squared using the power rule. What chain rule states is that you're going to take these two and multiply them together, which is exactly what I did down here. And then we can't have it in terms of u. The original function is in terms of x. So we must get this in terms of x. Well, what does u equal? U equals x cubed plus 1. So what we do is we substitute what u is, x cubed plus 1, back in. We rewrite it nicely, and we get the final answer. That is using the correct terminology. Now, you want, the way that I'm going to try to look at it is take the derivative of the outside. The derivative of the outside is something to the 1/2, which we basically called u to the 1/2 here. Take the derivative of that. So the derivative of that is that raised to the negative 1/2. Keep the inside the same, the inside x cubed plus 1, multiplied by the derivative of the inside, which is 3x squared. Now we want to rewrite this so that it looks nice. Anything raised to the negative power is put in the denominator. So x cubed plus 1, and the 2 is in the denominator also, so we'll put that out in front. 3x squared is really over 1, that's in the numerator, so we'll put that here. And then you could just rewrite this as that. And so, how I like to look at it, how it's going to be easier for you, is derivative of the outside, keep the inside the same, times the derivative of the inside. Hopefully this is starting to click a little. If not, we have many more examples, don't you worry. So looking at the next example. The inside, the outside. So the derivative of the outside is sine of something, negative sine of something, times keep the inside the same, x squared, multiplied by the derivative of the inside, 2x. Well, we want to rewrite this to make it look nicer. So negative 2x sine of x squared. Notice that we get the same answer, just a little quicker. So look at this one. What is the larger function? E raised to the small function 3x minus 1. Well, we haven't gotten into what the derivative of e is yet. Technically, we will get to that later. Why I have it in these notes, I don't know. But you guys learned from last year that the derivative of e is just e to whatever. So, if we have f prime of x equaling the derivative of the outside, e, to the, keep the inside the same, minus the derivative, multiplied by the derivative of the inside. The derivative of the inside is just 3. Well, we'll rewrite this nicely. 3 goes out in front, e to the 3x minus 1. I want you guys to pause the video and use the method that I say. Derivative of the outside, keep the inside the same, multiplied by the derivative of the inside, and try it on this one. So pause it, please. And so what we did here was, this is the inside. This is the inside, the derivative of the inside. So we brought the 1/2 out, raised it to the negative 1/2, the derivative of the inside, 3x squared plus 9. Multiplied the two together, negative power means in the denominator, multiplied by, we can really put that over 1. And so our final answer, 3x squared plus 9 over 2 square roots of x cubed plus 9x plus 2. How can we rewrite f of x equals x cosine squared of x? Well, we can rewrite this as cosine of x all squared. This is going to help you non-stop in the rest of calculus. If you can recognize this, if you can't recognize that, you're going to be in big trouble. So, f prime of x, inside, outside. So, if we take the derivative of the outside, 2, parentheses to the first, keep the inside the same, cosine x, multiplied by the derivative of the inside. The derivative of the inside is negative sine x. And so what do we get as our final answer? Negative and 2 are out in front. Cosine x times sine x. Now you don't need the dot there, of course. You could just write negative 2 cosine x sine x. But again, this is the derivative of it. Don't think that that's the derivative of the inside. Let's look at this one. Why don't you guys try this one on your own, actually. So pause the video, please, and try this one on your own. So again here, this is the inside. And so we've got the derivative of the outside, sine. The derivative of sine is cosine. Leave the inside the same, multiplied by the derivative of the inside. The derivative of 2x is just 2. The derivative of pi over 4 is a constant. That's 0. So we just got 2. So we're just going to get 2 cosine of 2x plus pi over 4. That's it. This one's going to be a little more tricky because what do you notice that we have? We have a quotient inside a power. So nothing changes. It's just going to be a little more difficult. Don't you think, though, that it's anything awful? The derivative of the outside, 4. Keep the inside the same. 4x cubed is the derivative of that. So bring the 4 out, subtract 1 from the exponent, keep the inside the same. Multiplied by the derivative of the inside. What I like to do is find the derivative of the inside when it's something more difficult to the side, so we don't actually do it all out here. So we have a quotient, so low, d high, minus high, d low, all over low squared. Well, we're going to get x minus 1 minus x minus 1 all over x minus 1 squared. The x's are gone, you get negative 2 over x minus 1 squared. That's the derivative of that. That's what's going to go in for the derivative of the inside. Now, this right here looks a lot nicer than doing all that work over there. So, notice that this 4 is outside of this, what's being cubed, so I can multiply the negative 2 and the 4 together to get negative 8 over or multiplied by x plus 1 cubed. And now here's something tricky. You guys need to know that x plus 1 over x minus 1, say this is cubed, equals x plus 1 cubed over x minus 1 cubed. It's the same thing. The cubed goes to both the numerator and denominator. So I can rewrite this as negative 8x plus 1 cubed. Notice that this is x minus 1 cubed. This is x minus 1 squared. I can write it to the fifth. 3 plus 2. I can get to the fifth. I'm done. That is our answer. Made it look easy. I know it's not as simple as that. Okay, notice that we have a chain rule inside of a chain rule, and this is the fun part. I'm going to set this, I'm going to rewrite this, and then I want you to do it. We can rewrite this as sine of cosine of 4x, this, all squared. That's what that squared is. It's all squared. So, you're going to do a double chain rule here. Take the derivative of the outside. I'll just do it right now. Let's see here. The derivative of the outside, 2 times the derivative, or keep the inside the same, excuse me. Keep the inside the same. It's raised to the first. So we're good. So this is what we have next. We took that. That's what we have next. So multiplied by the derivative of the inside. The derivative of the inside, notice that this is the big function, this is the small function. So times the derivative of sine, which we know is cosine. Keep the inside the same. Okay? Multiplied by the derivative of the inside. So that's cosine. What's the derivative of cosine? Negative sine. Keep the inside the same. Finally, times the derivative of the inside, 4. And now we're going to rewrite this all out. So we've got 2 times 4, 8. And we cannot, oh, and we have a negative here, so we can put negative 8. We cannot combine any of this, so we're going to rewrite it out as sine cosine 4x multiplied by cosine of cosine 4x multiplied by sine of 4x. And that is our answer. Please rewatch that if you need to. We just kept going in the inside. Derivative of the outside, keep the inside the same. Derivative of this outside, keep that inside the same. Derivative of that outside, which is cosine, keep the inside the same. And so on. Okay? We kept going one at a time here. Okay. With this one, I want you guys to try to take the derivative of h prime of x. That's going to give us the slope at x. So try to do this one on your own. And so hopefully you got this answer. If you didn't, I'm just going to go through it a little quick here. Take the derivative of the outside, 3. Keep the inside the same. So subtract 1 from the power. Multiplied, most likely many of you missed this step, multiplied by the derivative of the inside. The derivative of f of x is f prime of x. Find the derivative at x equals 0. Plug in 0 wherever you see it. Use the information given, which is right here, to plug in. You get h prime of 0 to equal 2. That is your slope at x equals 2. And then you have your point and slope, and you get your equation. You can try this one if you want. You can pause it. I'm not going to explain it though, but I will get you the answer. And there's the answer to the next problem. For the final problem, I'm going to do 2 of these, and then you guys can do the rest of them for class. So we just did this problem basically in the last one. When you take the derivative of this, you're going to take the derivative of the outside multiplied by the derivative of the inside. So f prime of g of x multiplied by g prime of x. Find it at x equals 3. So I found f prime of g of 3 using the table, G of 3, and good luck.